was exploring a set of data that showed the mean was 99 and the variance was 81. Find the standard deviation. Now, what you need to remember about this is the standard deviation is always the square root of the variance. Standard deviation is always the square root of the variance. In this case, the square root of 81 is 9. Okay, number 11. Probabilities, winnings, and expected value. The way we do expected value is we do how much you would win times the probability of winning. In this case, it would be 50 times 3/20, which works out to 7.5. And then 100 times 2/5, which works out to 40. 150 times 2/10, which works out to 30. And 200 times 1/4, which works out to 50. Then you add up all of the results or the products. Add them all up, you come up with 127.50. So the expected value of winnings, when you consider what you would win and the probability of winning it, is about 127.50. Okay, number 12. Order the following z-scores. Your sheet will say z-scores. Mine didn't. I had to go back, edit them, and reload the sheets for you. Order the following z-scores from closest to the mean to furthest from the mean. The closest score to the mean is negative. I can't believe I thought that was negative 0.05. Let's do a little editing here. Let's go to here, ready? Edit text and images. Okay, so I'll be able to do that in just a minute. Ready? Add text. This is the correct answer. The smallest one here is 0.15. That's the closest one to 0. Okay. Next up. Come on. This is because it doesn't recognize my handwriting. Okay, so I tried to change the answers. I'm not going to be able to. I'll change them on the other sheet. Okay, so edit. Let's just go to take a snapshot. That'll back out of this. Okay. Sorry about this mistake that I just found here. Okay, so the correct answer here should read 0.15 because that's the smallest. The next smallest would be negative 0.2. Okay, so it actually goes, the first two go in the order of the question right here, 0.15 and negative 0.2, then negative 0.5, then 1.05. So you take the absolute value of each of these and the smallest one goes first. Sorry, I thought this was negative 0.05. I mistook where the decimal place was. Okay, number 13. Suppose your statistics professor graded a test with your z-score. You earned a 4.2 on a test. That's your z-score, with a mean of 65 and a standard deviation of 5. You needed to score at least a 96. Should you be happy? Well, if you scored a 4.2 of a z-score and the standard deviation was 5, 4.2 times 5 works out to be 21. So that means you're 21 points above the mean. So you take the mean, which is 65, add 21, and you get 86. You needed a 96. You would not be happy. Next, a little more z-score stuff here. The test scores for the quantitative reasoning section of the GRE are normally distributed. The mean score is 150, standard deviation 8.75. It lists 4 test scores, but it says here, only find the z-score for 138. So 138 minus 150 is negative 12. Divided by 8.75 is negative 1.3714. Number 14, evaluate x equals 9, 5, 4, 3. Evaluate if x equals the sum of x squareds plus 3. So I square each of them because I have to find the summation of those things squared. 9 squared is 81, 5 squared is 25, 4 squared is 16, 3 squared is 9. I add those up, I get 131. Add 3 to that because of this little plus 3 at the end here. And you get 134. Number 15, x can equal 1, 2, 3, or 4. And it says now do -3 times the sums of the x minus 5. So I have to take 5 from each of these. That's -4, -3, -2, -1. Then, since it's a summation, I have to add them all up. I add them up, the sum is -10. And then I have to take that and multiply by -3, so I get positive 30. Okay? Next one, we're going to get into a whole bunch of normal CDFs. I'm going to stop this video at this point because I want to correct those two that we were doing before.